Bernoulli principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid potential energy. Although Bernoulli discovered that pressure decreased when the flow speed increased, it was actually Leonhard Euler who created Bernoulli's equation. Bernoulli equation can be applied to different types of fluid which result in various forms of the equation. The simplest form of Bernoulli's equation is by using incompressible flow. Incompressible flow are fluid and gas with a low Mach number with the density of the fluid being constant, regardless of the pressure flow.
The objectives of this experiment is to demonstrate the different flow regimes which occur within a convergent-divergent nozzle. Secondly, to measure the stagnation and static pressure taking the length of the nozzle. Thirdly, to compare the experimental and theoretical value. And lastly, to identify the approximate location of any shock waves. This is the result of F-flow through the converging and diverging section experiment.
This is the calculation we can obtain from the result of our experiment. From a graph of static pressure and total pressure versus distance, we can define that the distance increased, the total pressure increased, but the static pressure was decreased. Based on a graph of velocity versus distance, we can obtain the velocity is directly proportional to distance.
Experiment that when the F-flow passes between the converging and diverging sections, the value of H1 decreases, while the value of H2 increases as the value of X increases. This is due to a rapid reduction in the pressure of fluid passing through the tiny cross-section of the throat, resulting in an increase in flow velocity. We can compute the static pressure, total pressure, and air velocity using the value of H1 and H2.
To sum up, the objective of the experiment have been achieved by the knowledge of the pressure mass flow rate characteristic for convergent divergent duct, and all the pressure and mass flow rate have been recorded in the experimental result data and graph. From the experiment, it is found out that the flow is influenced by the injected pressure, the area-throat ratio, and the difference between the inlet and exit pressure. The problem faced throughout this experiment, these variations are due to human factors such as parallax error. The recommendation for the problem is make sure the position of our eyes must be 90 degrees perpendicular to the focusing object.